Next topic I am going to discuss about the doubling time of population. So what is doubling time of population? Doubling time of population means the time for the population becomes double of its present or initial size. Okay, the time for the population becomes double of its present or initial size. Okay, and now from the exponential growth equation we can write nt equal to n0 into e to the power rt, where r is the growth constant, that means exponential growth constant. So now according to definition of doubling time, nt is equal to 2n0. So nt equal to 2n0, that means population becomes double of its present size, okay, or initial size. Now at doubling time it is denoted by small t suffix d. Okay, so now at this time the this equation becomes 2n0 is equal to n0 into the power rtd. Okay, now from this equation we get td equal to ln2 by r, okay, is equal to 0.693 by r. Now r always taken in a percentage. Okay, now this is the doubling time of population. That means in that case growth rate constant is growth rate constant increase. In that case growth rate constant always positive in nature. Now in case of half life, so half life means the time required for the population becomes half of its present or initial size. Now this time this population is called half lifetime of population. The half lifetime population means the time required for the population becomes half of its initial size. Okay, and this is called half life of pollution, half life of population. Now half life of population is denoted by t half. Okay, in case of decay, it is called a decay constant. Why this is called decay constant? Because population becomes population decreases. Okay, so that means in case of decay, the rate constant of growth and rate constant of decay may not be same. Okay, so now exponential decay will be the nt equal to n0 e to the power minus r1t. Here minus sign indicates decay, that means r1 indicates decay rate constant. So minus sign indicates means decay, that means population decreases, okay, than that of its initial size. Okay, now in half lifetime, that means nt equal to n0 by 2, and then t and half lifetime is denoted by t half. Okay, now at t half, that means this equation becomes n0 by 2 equal to n0 e to the power minus r1 t half. Now from the so now next from this value we get t half equal to ln2 by r1, that means 0.693 by r1. In percentage, t half is equal to 69.3 by r1 percentage. Now under condition of similar growth and decay rate, that means when r is equal to r1, then the doubling time and the half life become equal. That means when growth rate and decay rate both are equal, then the doubling time and half life time is also equal. Okay, now next I am going to discuss about the limitation of exponential growth. Now there are some limitation of exponential growth, because in exponential growth model it is in exponential growth model the number of population increases exponentially. Due to increasing population, we are using our natural resources like fossil fuels and minerals. If the population increases or population growth takes place exponentially, then within a short time our resources will exhausted. In exponential growth, with increasing time, population growth also increases exponentially. So now in that case we have to use our natural resources. Okay, that means if population increases exponentially, then after a short period all the resources will exhausted. Okay, and another point is the simple exponential growth model can serve as well for short period time, but small growth rate constant cannot continue for the long period of time. That means simple exponential growth model can serve us well for the short period time, but it is not applicable for the long period of time, because in long period of time, that means population growth increases exponentially. So if population growth increases exponentially, then our natural resources will be exhausted after a certain period. Okay, now due to this exponential growth, due to this limitation of exponential growth model, a new model is introduced. Okay, and the next model I will discuss in your next class.